Hey everyone, welcome to the Tellor community call, uh, July 13th. So should be a relatively quick call. Don't have too many updates for you guys. Maybe Mike does. First off, Tally, do you want to stand up? Be our model.
Okay.
Let's go. Here we
Yeah,
go.
we got new swag.
It's
Um,
charcoal this time.
Yeah.
so the
It's a
new
good one.
swag is here. Mike, how are we distributing those? Do we have any way, or we're still TBD?
TBD, but let us know. So we got a bunch of them in. Um, Actually, we didn't get as many as we can get in. We wanted to test out the new design first in person, and we really like it, so we're going to get more. And for those of you who don't know, we're going a large contingent of tellers going to be at ECC in Paris, leaving just this weekend. So we need to have some swag to give out to people out there. But we're gonna have a bunch left over, and we're gonna obviously have, we're open to giving those things away as bounties as well. But if anybody is interested in them, um, we'd be open to selling them at cost, or just um,
We
doing
don't
some.
want to do like an auction, like the Uniswap socks or something like that.
Yes, we haven't really decided, but we wanted to get some because we know we've had people ask us if we could, if there's any shirts for sale, and so we wanted to get more shirts than we typically do. In the past, we just got shirts for the team because we were going to an event, and but now we have a little bit more of we have a larger team and a bigger budget, and we want to make some swag available to our community. So. They're really nice shirts and they won't be expensive, but just let us know if you're interested. And we also have more ideas for more fun shirts than just a typical Teller shirt, but stuff that's more meant for the community. But talk to Ryan or I about any of that.
Cool. Yeah. It's exciting. Always getting swag.
The shirts are
And
great. I'm excited about it.
shirts are cool.
We're gonna have tote bags and hats. And some other stuff. We were talking about bandanas just yesterday, and I think this is an excellent idea that Nick had. So, um,
Not
let,
bandanas. I wanted headbands. These are different.
oh,
Like working out?
No, like I want like the ninja headbands.
yeah,
Oh yeah.
that's a
Not a
bandana that's rolled up
uh,
into a thing. It's the same thing. It's a big square cloth that you turn into a ninja
anyway. Um
amateur.
man. But we do. I sent a T-shirt last time. The last person who actually got a T-shirt was somebody did get a Teller tattoo, and I sent them a free T-shirt for getting a Teller tattoo. So
Wow.
if you get a Teller tattoo, the precedent is set. We'll send you a T-shirt.
Oh, guaranteed.
Yeah. Okay. Onto some more serious stuff. So we're doing Teller X development right now. Things are looking good, so we should be hopefully done testing over the next few weeks. Um, Other pieces that we're looking for kind of community interaction on would be, well, we have what's called the parachute contract. So this is something that we're kind of open about. Whenever the last hack of Teller happened, we put back in the deity contract, and we're going to throw it away here very shortly. But we're not just throwing it away to the zero address, we're throwing it away to what's called a parachute contract. um, we've gotten it audited. We're continuing to do more audits on it. The idea is that basically it is the zero address unless certain conditions happen. So like one of those conditions would be like you mint the total supply of the contract, or you freeze the entire Teller contract. So if like the whole Teller contract freezes like it did last time, we get the deity back. If the if you can somehow hack the Teller contract and mint yourself new tokens, you can get the deity back. It's a weird sort of structure in your mind because these are things that if we coded Teller right, these things should never happen. Um, but like in the past, they did happen, and we've had to fix them. So just making it it's one of those things where, because most of the times that like if we do have a bug or a vulnerability in our smart contract code, which has happened a couple times, they usually just reach out to me on Discord or something like that, and without making it public, and it's always tough to fix those things. So being able to, you know, if there are any other serious bugs, fingers crossed, you know, we've been doing this now for 2 years. The smart contracts do get more and more robust with each iteration, just because they're live and hold more money. But just in case, we're launching this parachute, so go have a look. Timeline probably for throwing away the deity would be in the next month, so just letting you guys know.
And if anybody has any extra questions, or if you're watching this and you're not familiar with the whole admin key thing, feel free to reach out to us. We've talked about it on several of these calls, but if you're new, we understand you might not be aware of any of that. So just shoot us a DM and we can explain it.
Cool. And then obviously, the big reason that you guys are here today. Mike, would we have any other announcements first?
Not off the top of my head.
When's Brenda's speech? If people are watching ETC next week, I think we have a community call in between then, right?
I think it's the 21st, but
okay, we'll send it out. So keep an eye open. Brenda's going to be speaking at ETC. And yeah, and if you guys are over in Paris and want to meet anybody on the team, reach out to us. We'd be happy to meet up with you guys. I won't be there, but I'm sure the other people would be happy to meet up with you. And now other things, big reason you guys are here. Our intern, Chris, is presenting his first project that he did. So Chris, you want to give him a little bit of a background on it? And yeah, floor is yours. So yeah, sure. I think none of us have any. I think I know what you're doing and I looked at it, but I don't think anybody else has even looked at what you've done. So
it should be pretty exciting for sure. Yes. Yeah. I don't know if I have the ability to share my screen, but
hold on.
Sounds good. Yeah. I had a little intro ready, so I think it should be good. Yeah. Okay. There we go. So hopefully everyone can see that. I'll be looking up and down just to look at my monitor, but yeah, this is kind of the paper that I'll be going through. So I guess I can reintroduce myself again, but as Nick said, I'm Chris. I'm a rising sophomore at Stanford studying CS, and I'm also Tellor's newest software engineering / development intern. And today I'll be giving you guys a talk on some of the research that I've done over the last couple of weeks, which is essentially taking a data-driven analysis on the differences between different oracles, which I know is often a topic of heavy discussion within the Tellor community, whether that's in our Discord, Telegram, or other avenues. So to kind of give a little bit of context on myself, you know, before coming to Tellor, I definitely had a bit of knowledge on crypto and developing on the blockchain, but I definitely needed to acquaint myself a lot more with the oracle problem. And to kind of ground that in more context, I think that, you know, when you have this development on the blockchain with different smart contracts, you know, despite the many utilities that you have, I think one of the biggest limiting factors is the inability to get data from outside of the blockchain onto the blockchain. So whether that data is anything from the weather to generating random numbers or even price feeds of different currencies, being able to have mechanisms that retrieve data from off the blockchain and put them into your smart contracts is something that's extremely important. And that's where oracles come in. So in this report, I'll be giving you guys a quick look at different oracles, taking a more objective standpoint and just understanding how different oracles perform compared to one another. And so to look at the different oracles that I was looking at, of course, I decided to focus on Tellor, but I also looked at a couple others. I know that, you know, a lot of people refer to the industry standard as Chainlink, and I also decided to look at the band protocol and the DIA protocol. And to give you guys also, if you guys want a bit of complimentary reading, one resource that I did link was a great write-up written by our community manager, Spuddy, on our Reddit, which kind of talks about, you know, from a different lens, the differences between all of these different oracles, right? So what platform these protocols are built on, how the projects are funded, etc. So if you guys want to take a look at that before looking at the data-driven report, I think it would give a lot of color onto the analysis that I give. But looking a little bit at how I implemented it from more of a technical perspective, it was really a specific process. And I know that people who are more familiar with blockchain development probably just see this as something that they do every day. But in terms of a general overview, it was pretty much as simple as, finding the address of each Oracle smart contract on the blockchain, which is typically featured somewhere on their documentation on their website, getting the contract's ABI in order to determine what functions I could use to interact with them. And of course, using a framework like web3.py or web3.js in order to connect to one of these project smart contracts, invoke the proper arguments, and then calculate each of the metrics accordingly. And so in the report, I give a little bit of a code snippet that you can use using Python. And then I know that after the call, we can also provide the GitHub repository, and it's also on the Tellor organization repository. I believe it's Oracle diffs. So you guys can actually run the scripts yourselves and take a look at some of the work that I've done. So now that you guys have a little bit of the background and a little bit of the process, I can dive a little bit into the data analysis, which the first thing that I decided to key in on was just looking at the real-time values, right? The pure price feeds. So I decided to key in on 3 different conversions, specifically BTC to USD, ETH to USD, and Ample to USD, with the latter being included specifically due to the Ampliford proposal. So for each of these oracles, I decided to utilize the below functions from their ABIs. Again, I think this is more of speaking anecdotally and talking about my experience with them. But for example, for Tellor, the function that you would call is something like get current value, which takes a request ID. And what I enjoy about working with Tellor, again, is that they have all of their data feeds nicely organized in a reference page on their website. So it's really easy to see the ID, look at the data that it corresponds to, and grab that value. For a protocol like Chainlink, it's a little bit different. And I'll discuss a little bit more about sort of my conclusions from the differences. But what they actually do is that for each of their price feeds, they deploy a different smart contract and have a different address for them on whatever chain that you're looking at. And so, for example, this is on the Ethereum mainnet. And then you're able to essentially use each of those smart contract addresses, load them in when you're using Web3, and then query the values that way. So personally, I found that not as straightforward, or at least as easily to use as something like Tellor. And I can talk a little bit more about what I believe, or how I think that relates to the bigger picture of looking at oracles later on. But for example, for Band, again, these are the last couple of bits that I'll mention about the ABI. But for Band, I think that for both Band and Dia, it's a little bit less efficient as well. Whereas, for example, they're taking 2 strings. So for example, for get reference data, you have to input both the base and the quote, which might be a little bit more verbose than having just put in an ID. And then for Dia, I believe that the string name actually has to be the full name of the string. So whether that's, Bitcoin, the entire string, or Litecoin. So, I was just speaking anecdotally to my experience working with development. But after being able to use and utilize all of those functions, I was able to come up with the following table, which I updated around July 8th. So I want to say that was last Thursday at around 11:45 p.m. EST. So these are just the values that I had updated. And again, I think with any oracle, you can expect, any 2 oracles to have perfect values that match up together. But what I will say is the important thing to understand is understanding kind of the consistency. So looking at the historical price data and seeing whether or not you can truly rely on these values to be consistent as you use them throughout your projects. So the next metric that I decided to look at was exactly that, right? Getting the historical data. Now, again, from a technical perspective, it was relatively simple. The one caveat that I will acknowledge, though, is that due to the limitations of specific oracles and the smart contracts they have deployed on the mainnet, I was actually only really able to focus in on both Tellor and Chainlink's historical data and not really have a lot of avenues to get the historical data for Band and Dia protocols. And again, I'll talk a little bit more about that at the end of the talk. But from a more technical overview, again, it's pretty much as simple as saying, okay, for Tellor, there's a get data before function, and for Chainlink, there's a get round data. So when you query the most current value, you get either the timestamp or the round ID, and then you can just use a loop to kind of go back in time and get all of the values up until a certain amount of time. And so that's what I was able to do, right? So looking at the historical price feeds, these are, I believe I set the parameters for the last 5 days before July 8th, 2021. So this is what the data would look like for BTC to USD and for ETH to USD. So again, you can see that the data doesn't necessarily perfectly align, but I do think that they're relatively both consistent, and they show, for example, the same peaks, the same troughs throughout the time frame that we're analyzing. And if I wanted to explore even more data, I actually added that a little bit at the end, but looking a little bit at some of the longer prices, you can see that even then, the prices still seem to align over time, and you can still see the general trends moving forward, even as you look at a longer period of time in terms of the historical data. So that's for BTC and ETH. And then going up to Ample, I believe the graph might not look as smooth just because Chainlink doesn't update the value of Ample as frequently as Tellor does. So that's just something to be taken with a grain of salt. And looking at the average time between each request or the time to update each value, I know that's something that's not necessarily super important. And I don't think that, looking at the absolute time is important to all of the foundations of different protocols, for example, for Tellor. But I think it's important nonetheless to understand just how fresh the data is and just how often it's being updated, and whether it's easy to assume that you'll have consistency with regard to the amount of times that the values are updated. So in this case, I decided to look at the average time between each request, right? So looking at it over time, for example, for BTC to USD, I think there's a couple of key things that we can look at. So speaking quantitatively, in the case of BTC to USD, Chainlink, in terms of an absolute, takes more time to update their values compared to Tellor. But I think what sheds more light on the topic is just looking at the overall graphs and the shapes, right? So for example, looking at the Chainlink graph, you can see that there's a lot more erraticness in the amount of time that it takes to update or fulfill a request for a new value, right? So for example, sometimes it goes to around 2,000 seconds in between. Sometimes it can go as low as 200. And there's even a way to quantify that by just looking at the pure range of the data, right? So for example, the lowest point for Chainlink is at around 200, 250, and the highest point is around 3,500. So the range is relatively large at around 3,300 or 3,250 seconds in order to fulfill a request. Whereas with Tellor, sure. I mean, I don't think that it is purely absolute in the sense that one will always beat the other protocol, but you can see that, for example, for most of the time frame, you can typically expect that the average time that they update their requests hovers around 1,500 seconds, which I think is good. So looking forward, that was specifically for looking at the conversion of BTC to USD. For ETH to USD, I would say that in this case, Chainlink actually takes less time compared to Tellor in this case. And again, I would actually just look at this and say, I still see a lot of that same consistency where, again, you can kind of see the average time taking around 1,500 seconds for Tellor. But in this case, I would actually admit that there is an even amount of erraticness, especially a little bit past this point right here. So again, I think it really can depend on the different conversions, but here was the data that I was able to accumulate on that end of the spectrum. So for Ample, I decided to just pull the data in, but I believe that it's based more primarily on just how often Chainlink updates their values. And so I thought it would be kind of an unfair comparison to look at, the average time it would take to update for both Tellor and Chainlink in this case. But to kind of piggyback off of that idea, when looking at, for example, the average or the time graph for BTC to USD, I wanted to find another way to kind of ground that idea of the erraticness of Chainlink in a different distribution. And so what I decided to do was, for this time period, I would grab these values and actually plot them as a histogram so that I could kind of look at the spread and the shape, and even quantify some of those a little bit, right? So looking at the histogram of the time requests, I think that for Tellor, for example, there's a couple of different observations you can make. So the first thing is, the mean and the median of the Tellor times for this specific time period. The difference between them is relatively small. So that means that even though there might be a bit of skewedness, overall, you can expect that the distribution can be relatively uniform, right? Or at least the difference isn't too drastic. And even if you were to just look at the overall shape of the histogram, you would see that it's, relatively unimodal, right? The peak is somewhere around the 1,250 to 1,500 second area. And even though you might acknowledge maybe a couple of potential outliers, greater than 2,500 seconds, you can see that the distribution still looks relatively uniform. And the variance, I think, reflects that as well, right? You have a standard deviation of around 502 seconds. And even though that might seem a little bit on the big side, if you look at Chainlink's, it kind of gets more magnified, where the standard deviation is actually twice as big as that of Tellor's, right? And then looking also at the different statistics, you can see that the mean and the median, again, there is a difference, but the difference between the mean and the median is much greater, which would indicate that there is a bit more skewedness with regards to the data. And again, even just looking at it visually, right? Whereas you can acknowledge that with the Tellor times, it would appear to be unimodal. For Chainlinks, you could say that it might be bimodal with, peaks at around 500 seconds and around 2000 seconds. And you might even be able to make the case that it's multimodal given the amount of times that it appears to be 3,500 seconds. So that's just a statistical observation of, visualizing the consistency in updating the values or fulfilling the requests for both Tellor and Chainlink in terms of time. So the last little metric that involves all of the oracles outside of just grabbing the real-time value is just estimating the gas prices or estimating the amount of gas that it would take to request a singular or the most current value from each of these oracle protocols, right? And again, it's one of those things where I feel like it's not super convincing that there is an inherent, performance difference between all of the oracles. I mean, if you were to ignore the units, sure, Tellor versus band protocol is a difference of like 40,000 to 30,000. But when you're looking at units of GWAY, it's not something that's super consequential and is something that is going to be incredibly gas intensive. So that's just one acknowledgement to make on that side. And so to kind of couple the idea of gas prices and the idea of updating values together, the last little piece was more of a regression analysis piece where it looks at both how the time to fulfill each request changes with fluctuating gas prices due to demand on the blockchain, right? So exactly in terms of like the implementation level, what I would do is for looking at the timestamps of when each of these requests were fulfilled and looking at those time differences, I would map those to the historical gas prices of when those requests were made or when those values were updated. And so from there, it would be interesting to look at the correlation between the time it would take to update versus the actual price or versus the actual gas prices at that time. So looking at something like Chainlink, I think that, again, just looking visually at the actual scatter plot, it's pretty clear to see that there's a lot of erraticness, and calculating the correlation coefficient actually shows that the R value is around 0.079, which would indicate a little to, if anything, very small positive correlation. But I do think that the other interesting thing is that quantitatively, that p-value is around 0.739, which is relatively big. So it's not, you can't really make a statistically significant conclusion that there is no complete correlation between the request time and the gas price for Chainlink. And I think that an avenue for further exploration would definitely be to get more of that data and see if a correlation does appear. And if so, what value it would be. And in the case of Tellor, again, if we start off with the visuals, I think that it's important to note that if you're looking at the values where the X values are in between 1,000 and 1,500 seconds, you can see that they seem to hover around that time despite the gas price, right? So you'll see a request that might take around like 1250 seconds and the price be around 2 times 10 to the 10th GWAY, and it might be 3 times 10 to the 10th GWAY. So I think that looking visually, that kind of makes that conclusion. And sure, looking at the correlation coefficient, it's much more on the greater end, right? It's about 0.3, which would indicate still a relatively small, but definitely a much bigger correlation between request time and gas price. But I do think that because the p-value is significantly smaller than that of Chainlink's, again, you can expect a little bit of that consistency and you can expect that that trend will continue. And again, even just looking at it from a high level, that makes sense, right? That, as the gas prices increases, the request times would also increase as well, just given the demand on the blockchain. Yes. So those were a lot of the quantitative analyses, and I kind of just wanted to end with a couple of concluding thoughts. In terms of looking at Tellor and Chainlink, I wasn't able to really find like a pure, like huge, grandiose difference between the performance of the two protocols. If you look at like their historical price feeds, they match relatively well and are both, have that consistency. I think the only notable thing to kind of key in on is that Tellor's average time to fulfill a request or kind of update their value varies much less than Chainlink's and is much more indicative of that consistency. But even then, I don't think it's too big of a difference. And there certainly isn't anything that indicates that either are too heavily correlated with fluctuations in gas prices. Although again, I think that the always biggest thing when you're looking at data analysis projects is, given the access to more data, would different trends appear? And I think that's certainly something to consider. Now, speaking from a qualitative standpoint, I think there are two notable observations on my end. So the first being kind of the ability to interact with the smart contracts, for example, with the band and the DIA protocols. I found them to be very limited. They basically do the bare minimum. So if you wanted to use in your project, for example, something like historical price feeds, or being able to look at the time it takes to service a request, mainly just for reference to see how fresh the data is being updated. There's no means of doing so by simply interacting with their smart contracts. And, again, I try not to take too subjective a standpoint, but I think that if we're kind of analyzing from like an organizational level, I think that the idea of transparency here is important. I think that on the level of giving more functionality and affording more information to users, I think that that's where Tellor and Chainlink might do a better job in that case. And once again, speaking from an anecdotal perspective, I can also speak on the ease of connecting to both Chainlink and Tellor's price feed data, specifically their historical price feeds. So if you can recall at the beginning, I mentioned when I was grabbing the most real-time value, Tellor's is simple as basically inputting a request ID and then being able to get the value that way. While for Chainlink, you would essentially have to define a new smart contract instance using Web3, since you'd have to get all of the specific addresses on the mainnet for each of the specific price feeds. And so again, I mean, you can speculate why that is. And I think that, from a development side, it shows at least a little bit of ease of use in Tellor's case. But I think that outside of like a lot of the buzzwords that you hear coming from people from Chainlink, whether it's, they were, Nick and Mike were talking about all the buzzwords from like all of like these extended nodes or node randomness and stuff. I think that at the core, you have to understand and think about just the idea of integrity and whether or not the technology that they're implementing is truly decentralized. And I think that being able to do this project kind of shed some light on not just the objective performances, but also just, if I think, these organizations are kind of implementing the technology in the way that they said they do. But yeah, that's pretty much my report. And yeah, I'm happy to share the work outside of it, but that was pretty much all that I had for today. So yeah.
Super cool, Chris. I think, yeah, some cool things. So I think first, if you look at like the gas price versus request times graph, it's a super interesting one. So first off, this is crypto. You're supposed to just hand draw the line to show whatever you want it to be. So you just, doesn't have to be straight.
Right.
Just put a little arrow and say this is how it works. But like, so with, obviously we need more data here. Because, if you guys can see, the G-Way gas prices are between 2 and 8. So the time he took this, it was a very, very low gas day. And we know for Tellor, for instance, before that 15-minute mark, it's a whole different game as far as competing for slots than after the 15-minute mark. I mean, Spuddy can even talk about that a little bit, but it's before the 15-minute mark, it's much more based on, actual mining and slots. And then after the 5th minute, it's much more based upon gas prices. But my guess is that even under 8 G-Way and things like that, the reward is almost always going to be really great, or greater than the cost whenever the gas price is that low. But once you start floating up into the 30, 50, 100 G-Way range, then it's like, okay, now we're gonna have to wait wait an hour before we submit. And I know Tellor does that. So, you would need to, and I don't know how Chainlink performs there. I'm guessing it would be roughly similar, but I honestly have no idea. So yeah, so there's that. And then, but you can see like, it looks like there's a whole bunch of submissions right before that 15-minute mark, which is actually very interesting. So it looks like the miners and people are more targeting to submit it before it opens up to the public, or maybe that's just some timestamp issues that you're hitting right around there. But I'm guessing you'll hit most of the things like right around or at 15 minutes. So other thoughts? What about you guys? Anybody else have questions?
I would need like a whole crash course in data analysis and how to read these and draw those conclusions. And you did a good job. I think a lot of it's, even for someone like me, like a layman, I think a lot of people watching this are also going to be laymen, need a little bit of explanation about it. But I think it wasn't that bad. Like I think I followed it really well. And so I definitely want to pull you aside, Chris, though, and sort of pick your brain a little further. So
Yeah.
I definitely want to be able to hopefully run this with a bigger sample and at different times a day, or just for like a longer period of time, just so that we can get a better idea of what's in actual, what's actually in production. But this is super interesting. It's, I really liked it, Chris.
one of my favorite parts of this was that you shared your process and you shared your experience of what it was like just collecting the data. Data analysis completely aside, I thought that was really fascinating, and I almost want to lean into that a little bit more. I think there's an appetite, I think, for an analysis and just in terms of like what it's like interacting with these smart contracts. What can you do? What can't you do? How many steps it takes? How many hoops you have to jump through.
And if there's anything we can do better, definitely
yes,
go update our documentation for us.
Yes.
And yeah, but let us know seriously. And then I think the one thing that maybe you could use a disclaimer in the paper would be like, as anyone who's here with Tellor knows, like it doesn't, just because you can put data on chain really fast, and let's say you even mimicked Coinbase's API and were crazy fast, didn't correlate with gas prices, and it was perfect. That doesn't mean you're decentralized in any way. In fact, there's you should be able to meet a minimum requirement as far as you can get data on chain in a consistent manner, I think. But as far as being a good oracle on chain goes, it's that's like the low bar. Like the high bar is like like Coinbase's API, if they just posted prices on chain every 2 minutes, it would be perfect. But that would be an awful oracle to use because it's run by a centralized party. So you're comparing things, but it like you have to like take it with a grain of salt, especially whenever comparing to Chainlink, which is where that's sort of our whole shtick about Chainlink, is that they don't meet that basic requirement of being semi-decentralized. So
it's a bit apples and oranges there.
Yes, but it is cool that we sort of compare well and hold our own, which is nice.
Yeah, this is purely like a data comparison,
right?
not like a structure comparison. So.
Yep.
Yeah, and then I would wonder, like, I think maybe for your next, we should do like, because this doesn't say anything about the costs. Like I know you looked at the cost to get data as far as get current value. That's actually the cost to like read it in your smart contract. The actual cost is, so like in Tellor, it's how much does it cost to add a tip and get that to the top. It's roughly the cost of gas, plus a little bit. But how much is it to get Chainlink in your smart contract and get a custom price feed updated? To be honest, we don't know. You got to negotiate that off chain. So maybe we'll have you go undercover and try and start a project and get some pricing from them. Yes. See what you can do. So if you can do that, man, you get a bonus for this internship.
Sounds good.
So, Spuddy, anything?
I don't know. What?
Cool.
I think that the submitting at the 15-minute mark might be because the strongest miners would be the same addresses, and that's like the 15-minute time limit for one address to submit. That's probably why they're submitting right before 15 minutes or at 15 minutes.
Yep.
And it's not that it's like the same miner, but like just the strongest miner would submit every 15 minutes.
Yeah, the people who are using MEV and stuff like that are submitting before.
I don't know. I don't know what they're using. They're using
Cool.
techniques beyond me.
All right. Well, Chris, thank you very much. We'll be passing this report out, hopefully getting it for more data, but thank you very much. Mike, on to questions.
Alrighty. I had them up. Lost in my sea of tabs. Okay, here we go. We have a few here. Doing some self-editing here. When Moon. Why is Tellor so low? I can't believe it because it's so young. Yes, probably. Let's see here. What are some of the advantages of Tellor, of having Tellor as your oracle instead of other oracles? I want to give this one to Chris. Based off of your analysis, how would you answer that question?
Yeah, I mean, I think I touched on a lot of those things. I think that just I mean, it's a very reliable in terms of its price feed data. I think that the consistency at which it updates all of the values is something that is always something that I'm important. Like, you know, if you're using Tellor in a project, you want to make sure that the data is relatively fresh in that regard. And I think that I don't know if this is something that's super important to all of those stakeholders, but again, I mean, just being able to be kind of honest about the promises that you're making about your oracle, I think is always important, right? The idea that we're truly decentralized and we're fulfilling a lot of the things that are in our white paper, I think is always something to kind of key in on. But, you know, I'm always happy to get other thoughts as well on that, but that would be what I would grab from my analysis for sure. Yeah.
Thank you. Next one is, can we please talk more about Tellor's future and present partnerships?
Oh.
Well, the future, we don't talk about the future partnerships until they're tangible because really a partnership is only is an act in the present.
Yeah, I mean, I was talking on Discord a little bit with somebody on this, and you know, there's a difference between, I think what we're more open towards is saying, like, here's some users who use us, or like, you know, maybe this is an example of how they're doing it. You can look at pros and cons. But what we don't want to do is there's a big like hype game in crypto where you say like, oh, we're partnering with this project, we're partnering with this chain, look at us going over here and doing this, and it's all just for marketing. And we want to stay kind of away from that. You know, like if you think about like what we ultimately want to be, like an Ethereum, nobody partners with Ethereum. You just go use Ethereum. You don't have to get them to put on their website your logo or anything like that, and you don't want them to. Because I mean, even we've found like anytime that we like want to announce a project or something like that, if it's ever before, then you get like 10 scam projects who come and are like, can we also partner with you and get a press release? And we're like, you know, we don't want to tell our community about you because you're, you know, gonna rug everyone. And you know, Chainlink, a lot of times there's a lot of sketchy projects out there that they partner with and then never launch. But you know, it all just feeds into that constant hype and news cycle, and we want to stay away from that. You know, it's we definitely know that we're still working on getting more users, and we're going to let you guys know whenever we get those good users and how they're using Tellor. But that's kind of the route that we want to take. We don't really want to do the hype game or make it seem shady, I guess.
Yeah. What we're not going to do is we're not going to partner with somebody that, you know, has some really arbitrary use case for Tellor that's not really a real use case of Tellor. Like they sort of integrate our price feed into their front end, which is inconsequential, and it's not, you know, it doesn't really have any effect on their security or their protocol or something like that. It's not an exciting use case. It's something, though, that we could easily sort of hype up and spin that it's some big deal, like it's a partnership with Google or something like that, but that we know is really just a manipulation of our audience. So we just won't do that. And we think that a lot of our community appreciates that about us. But we will, we will be really excited about the actual users that we have that use us for all the right reasons. Next one's a long one. This is curious what your approach to node randomness is. I know Chainlink, for example, on node randomness is not included into protocol's core, allowing greater flexibility. Also, interested in data quality. Chainlink said it supports free open APIs plus paid authenticated APIs, etc., proprietary private APIs through these modular external adapters. And then finally, accessibility, where Chainlink says they connect to all data requests via modular external adapters. So that's a mouthful. So hoping to get Tellor's info for these three things: node randomness, data quality, and accessibility. Thanks.
Yeah, I mean, we were talking about this a little bit before, kind of like right whenever, it's sort of, it's all meaningless. Like with Chainlink, your Oracle is like, your Oracle's only as good as, if you have a centralized choke point, it doesn't matter what anything else is. Like quit using these words like modular external adapters and things like that. Like it doesn't mean anything. You have a centralized point of failure, which is Sergey and whoever else gets to say who nodes are. And it doesn't matter if there's a million nodes or one node, they all have to go through this central choke point and they have full control over it, and there's nothing you can do about it. So it doesn't matter if they're randomly selected or not. The biggest point of failure and the reason that you wouldn't want to use them should not have anything to do with those or even their features. That said, we can talk about how it works in Tellor. So node randomness is a little bit different. There's not really that concept in Tellor since it's a competition. It's similar, like, like since we're like proof of work and not, whenever you're like a direct proof of stake system, then you have, how do you select the different validators? We don't have any selection mechanism for the validators. Anybody can jump in at any time. Like if you want to spin up 1,000 validators, go for it. It's more of like, Bitcoin doesn't have that problem in the same way we don't have that problem because we're not selecting them.
Right, the randomness comes from actually doing the proof of work.
Yeah, and I mean even in the next one, so we actually don't have that problem either, because we're sort of using gas costs as our limiting factor for randomly selecting. But it's one of those things where you could theoretically, we just allow anybody to, in TellorX, we allow anybody to push it anytime. There's not this limit per se to where like the next block you have to pick some validators. Like in TellorX or even Tellor now, like, well, Tellor now we have the proof of work thing, but in TellorX it's, you can have one block, you can have 1,000 blocks the next block, it doesn't matter. So there's not really that sort of direct comparison. What was the other question?
The other one was data quality, and I can just touch on that real quick.
Sure.
It goes back to the apples and oranges thing, or comparing Tellor to Coinbase's API. Like, you could say that having near instantaneous price updates is an evidence of high quality, but if it's from a centralized source like Coinbase, then it becomes a gray area or more of a philosophy question. And so our approach to data quality is the method that it gets on chain. Is it decentralized and censorship resistant and trustless? So we focus on that first. That's where our notion of quality comes from. Not things like, not that we don't care about speed and the things that we were just analyzing in the data analysis, but those things come secondary.
And there's definitely, there's two risk vectors when you're trying to get data on chain. There's the one side, you have how the Oracle actually functions and whether or not it's decentralized enough and can guarantee you a price feed, whether or not anybody is on, it's on the team working on it or not. And then there's the other aspect, which is where is the data coming from? Is it just one API? If that API comes down, then you're out of a price feed. If, depending on how you structure it, those are your two choke points. And whether it comes from some like paid API, that's a centralized service more than likely. And if the fee comes down, it comes down. You're not going to get a price fee. So anyway, I just wanted to make sure we touched on both of the types of risks that you have when you're bringing on data on chain and how you structure what you want on chain.
The last thing was accessibility. The notion of Chainlink, quote unquote, connects to all data requests via modular external adapters.
Doesn't that actually make it less accessible? Since you have to like get a different modular adapter for each feed.
Again,
I'm just picking on Chainlink now. Too much picking on Chainlink.
Hey man, we should come up with some cool words.
I was thinking about that earlier today.
Yeah.
We come up with some terms to define 100 articles all over the internet.
Super cyberpunk.
What's
terms.
cooler than Tellor X?
Yeah.
Yeah.
Anyway, any more, Mike?
The last one is, should I be holding TRB on an exchange? Will TRB lose value once Tellor X is launched? I would hope not. I have no idea what the market's going to do. But if this is, some people think that the Tellor X is going to be a new token, and so that'll affect TRB. That is not. TRB is the same token for Tellor X or for any future update. We're not changing the token. So hopefully that good news would be well received in the market, but we'll see. And
Yeah.
you can hold it on exchange if you want to. I would recommend a blend. If you're not comfortable with holding them in your wallet, like start small and get comfortable with doing that. It's part of being into crypto, is learning how to be your own custodian, but tiptoe with it, because people make mistakes and you can lose your money that way. And we've had a lot of experience helping people with that over this last year. So, and we're happy to help. We have a lot of experts here, on the team that no problem is too small for us to help you out with. If we have time, but we like to be good ambassadors for crypto in general. So if you're thinking about it, we'll help you hold your TRB in a safe way.
Awesome.
And that's
it. Well, thanks everyone for coming. Chris, thank you very much. It was a rock star presentation. It was really good. We'll send that out and see you guys all next week.